Hi, my name is Dr. Richard Thurkelson. I prefer to be addressed as Dr. Rich rather than Professor Thurkelson or anything like that, since that sounds a bit lofty to me. So, welcome. I'm looking forward to meeting each of you, hopefully, enriching you with a little knowledge of nutrition and biochemistry and having some fun in the process. This class is titled Western Nutrition and Biochemistry, and it's an introductory course for those topics. If some of you have taken chemistry or biology classes in the past, it might be a bit elementary, so you'll have to bear with me. But I hope you'll gain some practical knowledge and maybe educate me a little in the process. I don't necessarily think you have to take notes in this first class, but you're certainly welcome to if you like. There'll be a short quiz next week, as most weeks, just to make sure I'm getting through to you. So with that said, let's get started. The first half of the course will concentrate on biochemistry and introduce you to the basics of the topic and the terminology used in that science. In the second half of the course, we'll delve into the more practical application and talk about food as it relates to health and disease and the various diets that are popular in the United States and throughout the world. The human body runs on chemicals, the chemicals of life, biochemicals. These chemicals come from the air that we breathe, water, and food. The air we breathe is abundant, although clean air is becoming a challenge. Water is also abundant, though fresh drinking water is growing more and more scarce. Food, on the other hand, the more practical topic of this course, has a turbulent history. At one point, food shortage was a major concern. Hunters and gatherers were very physically active and thus lean and strong as they sought elusive game. Relatively recent technological advances in food production, however, led to a new era that was characterized by an overabundance of inexpensive food and comparatively little physical activity. Other shifts contributed to the changing way we ate. Women who had previously controlled most of the average family's food preparation entered the workplace in significant numbers, and the processed food industry began to capitalize on our need for fast, convenient food. This meant that fewer meals were being cooked at home, and since convenient foods were generally higher in calories than home-cooked meals, the average person's caloric intake increased dramatically. We began to eat less healthy food, more salt and fat and sugar. And we also ate more food because processed food is often designed as snack food and marketed to us in a way to cause us to eat continuously throughout the day. The changes in the way we ate led to an emergence of obesity as a recognized chronic disease with well-defined health consequences, and medical recommendations were made to try and address this growing health crisis. In response to this crisis, attention was focused on reducing fat in our diets, and the processed food industry responded by giving us what we wanted. Thus started the low-fat, no-fat craze. But they still had a vested interest in selling their products, so they found other ways to make the reduced fat products taste good. One way they did this was by adding significantly more sugar and other forms of sweeteners, like corn syrup, to almost everything we ate. This not only made the reduced fat foods more appealing, but it also increased their shelf life. The resulting increase in our intake of simple sugars fueled our modern epidemic of obesity and diabetes. These shifts in our food consumption patterns have led us to a point in history where our physiological adaptation, our ability to store energy as fat, has become maladaptive. The balance between food availability and energy expenditure has been disrupted, and it left us with an increase in the incidence of obesity over the past 60 years. An epidemic that the World Health Organization has labeled a worldwide public health crisis. This has led us to a great interest in the study of food and its effect on our health. Food has been broken down into three basic categories: carbohydrates, proteins, and lipids. And ever since these categories were defined, people have been trying to figure out exactly how much of each of these nutrients will optimize our health. This has led to all kinds of different opinions and diets that have confused the general public. A basic understanding of the nutrients can give us a helpful background for our discussions about food. So initially, we'll review the nutrients and how the body uses them. And later in this course, we'll focus on discussions about various diets and health. The first class will be an overview of the lessons to come. So let's start with some basics of carbohydrates. Dietary carbohydrates are combinations of sugar units that come in both simple and complex forms. Simple carbohydrates include the monosaccharides or single sugar units like glucose and fructose, as well as the disaccharides or two sugar units like sucrose or table sugar. Complex carbohydrates or polysaccharides include the dietary starches that our body can break down and digest, and also the indigestible polysaccharides that make up dietary fiber. During the process of digestion, carbohydrates are broken down and converted to glucose, which can then be metabolized by the body to produce usable energy in the form of ATP, which is the energy molecule that we use much like gasoline to run our cars. If our supply of fuel is high and the energy demands are low, glucose can be stored, and most of the time it's stored as adipose tissue, commonly known as body fat. Next, we'll look at proteins. Dietary proteins are also broken down into their component parts, amino acids, during the process of digestion. And these amino acids can be used to build and repair lean tissues in the body and perform many other important functions. But amino acids can also be broken down and used for energy. And if they're consumed in excess, they can contribute to fat stores in the body as well. Protein-rich foods, including animal and plant-based proteins, can also vary enormously in their quality and their implications for our long-term health. Proteins are also said to act as building blocks for the lean tissues of the body, but they serve many other important functions in the body, including regulation, supporting immune function, and a variety of other roles in our physiology. There are 20 types of amino acids needed to fulfill all of these functions, but only 9 of them are essential, meaning that our bodies can't make enough of them, so that we rely on getting these from our food. In general, animal sources of protein like fish and eggs provide all the essential amino acids in high enough concentrations that these foods are called complete proteins. In contrast, plant-based protein sources like beans, lentils, nuts, or tofu tend to be incomplete sources of protein. Now, it might seem that since plant-based proteins are incomplete in their nutrient content, that they're nutritionally inferior to animal-based proteins. But in fact, the health benefits of substituting plant-based proteins for animal-based ones, even for a few days a week, far outweighs the risk of falling short of amino acids. Plant-based proteins can be combined with other foods to provide a complete amino acid profile. In fact, many traditional food combinations like corn and black beans or rice and lentils are based on the principle of combining complementary proteins. Meals that contain vegetarian sources of protein also contain more fiber and less fat, especially saturated fat, than meals that feature animal-based protein. And even though saturated fat may not be as harmful as we once thought, it can still contribute to elevated levels of low-density lipoprotein cholesterol if we eat too much of it. So moderating our intake of red meat, for example, is still a sensible idea. In general, the typical Western diet contains more animal-based protein than we need to sustain good health. People who eat lots of plant food, eat a plant-based diet, tend to have much better health and better longevity than people who eat a heavy meat diet. So if you're thinking of trying a low-carb, high-protein diet, it's important to pay attention to the kinds of proteins that are being consumed and in what quantities. A diet high in animal protein, especially if it's a poor quality animal protein like processed meat or high-fat cuts, can be harmful to our health even if it leads to a weight loss in the short term. Dietary fats can also be broken down into smaller components and used for energy, or they can be stored as adipose tissue, depending on our energy needs. Fats are the most energy-dense macronutrient, providing 9 calories of energy for every gram. In contrast, carbohydrates and proteins provide only 4 calories per gram. Since it's more compact and valuable from a survival point of view, we've evolved to store excess nutrients as adipose tissue. And since evolution is far behind the Industrial Revolution, we have this nasty condition of obesity and its related health problems. For decades, the relationship between dietary fats and health was at the center of our attempts to understand the underlying cause of obesity. The debates over nutrition that you will hear, should we worry about fat? Should we worry about carbohydrates? Is the problem lack of fiber, etc.? All these are attempts to figure out what the culprit is in the problems related to the Western diet. People like to figure that out because you can just adjust that one thing and go on your merry way. But we haven't gotten that far, we haven't gotten that down yet. We don't know the answer to that question with any real confidence. Despite the important roles that fats play in our bodies, this entire category of food was shunned for most of the 20th century. This led to an enormous increase in the availability of fat-free and reduced fat foods. But in spite of this, or maybe because of it, obesity continues to rise even to this day. Today, awareness about the differences between the so-called good fats and the bad fats have allowed this important part of our food supply to make a comeback. But once again, the pendulum threatens to swing too far in the opposite direction. And it's not just an adipose tissue. Since the advent of marketing, processing, packaging, and distributing foods, the quality of our food matters just as much as the number of calories we consume. So within each category of macronutrients, we need to choose foods that will support our health rather than working against it. And not all nutrients are created equally when it comes to their effect on your health. So learning facts about the different food groups can help prevent us from becoming confused and potentially consuming a diet that's dangerous to our health. For example, recently a lot of attention has been focused on the fact that many of us are eating too many carbohydrates. There are lots of popular diet trends that encourage us to drastically reduce the carbohydrates in our diet, even to the point of eliminating or limiting our intake of fresh fruit. At the same time, some of these low-carb diets seem to suggest that protein and fats can be eaten freely. But a diet that's very high in animal protein with little fiber or not enough fruits and vegetables could leave us with serious health problems in the long run. In fact, the category carbohydrates includes a wide spectrum of foods, some of which are vitally important to our health and some of which can compromise it. Whole grains like brown rice and rolled oats are carbohydrates that provide our bodies with a usable source of energy, and bound together in that very same food is a significant amount of fiber, which slows the release of glucose into the bloodstream. The glycemic index of a food is the measure of the speed at which available glucose is released into the bloodstream after it's digested. A whole grain like brown rice or quinoa will result in a slower release of glucose and a more muted insulin response. On the other hand, a food that's high in refined carbohydrates like white bread or sugary sodas will lead to a more rapid release of glucose into the blood. In response to this, the body releases a large amount of insulin, the hormone in our bodies that lowers blood sugar. Because of spikes of glucose and insulin lead to less stable blood sugar levels, eating foods that are refined, especially highly processed carbohydrates, can result in an earlier return of hunger, tendency to overeat, and a path towards insulin resistance.
It's 7 o'clock.
The glycemic index of a food is lower when the food contains fiber or when it's eaten in combination with protein foods or foods containing some dietary fat. For people who are struggling to manage their weight or their blood sugar levels, eating foods that have a low glycemic index is especially important, but choosing low glycemic foods is generally a good idea for all of us. So when we talk about dietary carbohydrates, we're actually talking about a very broad family of foods, some that can be harmful to our long-term health and some that can support it. Learning how to choose the right foods within each nutrient category is one of the keys to better health and what I hope is the goal of this course. Dietary fats can be divided into two families, the saturated and the unsaturated fats. Saturated fats get their name from the fact that their fatty acids are saturated with hydrogen molecules. This means that they can lie flat and packed together densely, so saturated fats tend to be solids at room temperature. Animal fats like lard and butter are good examples. In contrast, the fatty acids that make up unsaturated fats are kinked in places where the double bonds between the carbon atoms cause the chains to be less saturated with hydrogen. This also means that these fatty acids don't pack together as tightly, leaving most unsaturated fats in the liquid form at room temperature. Omega-3 fatty acids are a special kind of unsaturated fatty acid with double bonds in specific positions of the hydrocarbon chain. They're found in high concentrations in fish oil and also some degree in nuts, flax seeds, and other vegetable oils. Omega-3 fatty acids are the only kind of fatty acid that the human body can't make, so they're essential for our health and they need to be consumed via the food we eat. Unsaturated fats can be naturally occurring, like the fats found in olive oil, nuts, and avocados, or they can be man-made or chemically manipulated to become unsaturated. These are fats found in some margarines and in the kinds of oils that are often used for repeated cooking and reheating in deep frying machines like the ones used in many fast food restaurants. The problem with chemically engineered unsaturated fats is that the chemical bonds between the carbon atoms are less stable, so they easily flip into a trans orientation rather than a cis orientation, and this is where we get the name trans fats. Trans fats are problematic for our health because they increase the amount of low-density lipoproteins, or LDLs, cholesterol in our blood, and they lower the amount of HDL, or high-density lipoproteins. By doing this, trans fats promote the formation of arterial plaques and increase the risk of heart disease. While saturated fats have also been shown to contribute to increases in LDL cholesterol, they haven't been shown to lower HDL cholesterol or to contribute to the development of arterial plaques as significantly as trans fats. So what's the bottom line when it comes to foods that contain fat? Probably the most sensible food recommendation is this: enjoy reasonable amounts of foods that contain mostly naturally occurring unsaturated fats like those found in olive oil, nuts, and avocados. Avoid all foods that contain trans fats, and enjoy a limited intake of foods like red meats that are high in saturated fats. With that bit of humble advice, let's get into some terminology that will be used when it comes to understanding nutrition, the reading of food labels, and the such. Starting with nutrition. So nutrition is the branch of science that seeks to understand food, its nutrients, how the body uses nutrients, and how inappropriate combinations or quantities of nutrients lead to ill health. It refers to all the processes by which we take in food and use it, including ingestion, digestion, absorption, and assimilation. The science of nutrition includes the areas of study of biological actions of nutrients, nutrient requirements, health effects of nutrient deficiencies and excesses, and diets in the real world. There are 8 principles that we are going to be governed by in this course. First one, nutrition represents the combined activities of countless food substances. The whole is greater than the sum of its parts. Secondly, vitamin supplements are not a panacea for good health. Third, there are virtually no nutrients in animal-based foods that are not provided by plants. Fourth, genes do not determine disease on their own. Genes function only by being activated or expressed, and nutrition plays a critical role in determining which genes, good and bad, are expressed. 5, the same nutrition that prevents disease in its early stages before diagnosis can also halt or reverse disease in its later stages after the diagnosis. 6, nutrition that is truly beneficial for one chronic disease will support health across the board. 7, nutrition can substantially control the adverse effects of noxious chemicals. And finally, 8, good nutrition creates health in all areas of our existence. All parts are interconnected. Okay, some definitions we're going to be going over. First of all, diet. Diet is defined as the food and drink consumed by a person from day to day. Sometimes people mistake that. They'll say, "How's your diet?" or something like that, and they'll think you're talking about some weight loss program or something. But it's a much broader term than that. It means anything, any food or drink consumed by a person. Ingestion is the process of taking food into the body through eating. Digestion is the breakdown of complex food molecules into simpler ones. Absorption is the movement of simple molecules from the digestive system to the circulatory system for dispersal throughout the body. Assimilation is the modification and incorporation of absorbed molecules into the structure of the organism. A kilocalorie versus a calorie. A kilocalorie is the unit used to measure the amount of energy in foods. 1 kilocalorie is the amount of energy needed to raise the temperature of 1 kilogram of water 1 degree centigrade. Now, just want you to note that kilo means 1,000. A kilocalorie is 1,000 times more heat energy than a calorie. A calorie is the amount of heat energy needed to raise the temperature of 1 gram of water 10 degrees centigrades. However, the amount of energy contained in food is usually called a calorie with a capital C. A dietary calorie is really a kilocalorie. If that's confusing, don't worry, we're going to go over that in more detail. So to review, there are 6 major classes of nutrients: carbohydrates, lipids, proteins, vitamins, minerals, and water. Carbohydrates, there's 2 types, simple and complex. Carbohydrates are the most abundant biomolecules on Earth. They're the source of energy for all living organisms. They're also called carbohydrates because they contain carbon, hydrogen, and oxygen atoms. Again, they're broken down into simple and complex carbohydrates. The simple carbohydrates taste sweet and stimulate the appetite. They're also used as building blocks in the manufacture of molecules such as nucleic acids. The complex carbohydrates include starch and glycogen. Glycogen is the storage form of carbohydrates in our bodies, usually mostly in the liver. They break down to monosaccharides to be used in cellular respiration to provide energy in the form of ATP molecules. We'll go over that in detail when we go over the Krebs cycle. Indigestible complex carbohydrate is also a source of fiber, which slows the absorption of nutrients and stimulates peristalsis. Monosaccharides, including glucose, galactose, and fructose. Glucose is the main source of energy for humans. Glucose is what we refer to when we talk about blood sugar. Galactose is derived from lactose, also in seaweed, gums, and sugar beets. And fructose is the sugar found in most fruits. Disaccharides are made up of two monosaccharides. For example, maltose is two glucose molecules formed when amylase breaks down starch, such as barley. It's also what's mostly found in beer. Lactose, milk sugar, is a disaccharide made up of glucose and galactose. And sucrose, which is your common table sugar, is a combination of glucose and fructose. Polysaccharides are chains of monosaccharides. They can be in the thousands, and it's the most common carbohydrate found in nature. Examples include starch, which is the main carbohydrate in the human diet, made up of long chains of glucose stored for energy in plants. Glycogen, as I mentioned, long chains of glucose used for energy and stored in animals and humans. And cellulose, long chains of glucose joined with hydrogen bonds that humans lack the enzymes to break. So they're used as fiber in our digestive system. A deficiency of carbohydrates results in fats being oxidized and converted to ATP. When carbohydrate is absent, most fats are metabolized to keto acids. If fats are not available for metabolism, the body will use protein as a source of energy. In extreme cases, this can be fatal because oxidation of protein results in an increase of toxic nitrogen-containing compounds. This is rare in the United States, as a more typical situation is the consumption of too much food. Excess consumption of carbohydrates results in the conversion of lipids and stores them as fat cells. Proteins. Proteins are composed of varying amino acids linked together in peptide bonds, and they are known as complete and incomplete proteins. A complete protein contains all the amino acids necessary for good health. Incomplete proteins are those that lack one or more essential amino acids. The human body can manufacture some amino acids, but cannot manufacture essential amino acids. Proteins have many important functions in the body and therefore not stored as an energy reserve. Because there are no protein reserves, the diet must provide an adequate amount on a daily basis. A high protein diet is not necessary to provide the lost protein from the body, which is about 50 grams a day. To maintain adequate levels of energy for bodily function, the sources of metabolism in order are ingested carbohydrates, ingested fats, ingested proteins, stored carbohydrates, stored fats, and finally structural proteins. This is good to know for when you're eating. The body prefers carbohydrates as the go-to source of energy. So your body will first use any carbohydrates that you're consuming as a source of energy. If you consume more carbohydrates than you are burning, you're going to store those carbohydrates in the form of adipose or fat, body fat. Lipids are also often called fats, but fats are only one of three subclasses of lipids. The three subclasses are phospholipids, steroids, and true fats. Phospholipids are the major components of cell membranes. And again, we'll go over that in later classes. They separate the cell contents from the exterior environment. Steroids are hormones that can help regulate a variety of body processes. They include cholesterol, and there's usually no need to include steroids in the diet. True fats are an excellent source of energy, providing 9 kilocalories of energy per gram as opposed to 4 kilocalories from carbohydrates or proteins. A teaspoon holds about 5 grams. Some fats provide essential fatty acids, linolenic and linoleic acids, needed for normal growth, blood clotting, and healthy skin. They also provide the medium for fat-soluble vitamins to be absorbed from the gut. Today's American culture doesn't like the sight of adipose, but stored fat is an insulator against cold and internal heat loss and serves as a shock absorber. It is evolutionarily the hedge against famine and freezing weather. Given the chance, the body hangs on to fat like gold treasure. The pleasant taste of many foods is the result of fats, and the ingestion provides a full feeling because they leave the stomach more slowly than other nutrients. Vitamins are organic molecules needed in minute amounts to maintain essential metabolic activities. Like essential amino acids and fatty acids, vitamins cannot be manufactured by the body. As a side note, vitamin D is not really a vitamin. It was named a vitamin because it was thought that it was only acquired through food. Later, it was found to be cholesterol converted by ultraviolet light into vitamin D. It should actually be labeled as a hormone, but for our purposes, it will continue to be considered a vitamin. Vitamins are not a source of energy, but rather an aid for specific enzymes to bring about biochemical changes. Some vitamins are incorporated into the structure of enzymes and called coenzymes. Excess consumption of vitamins can sometimes be unhealthy. For example, hypervitaminosis A causes joint pain, hair loss, and jaundice, a potentially fatal condition evoked by an acute or chronic excess of vitamin A, which is usually something in excess of 20,000 international units for 2 weeks or more. Minerals are elements found in nature that cannot be synthesized by the body. Because they are minerals, they're not broken down by metabolism or cooking. They retain their chemical characteristics whether in food or in the body. Minerals can function as regulators, activators, transmitters, and controllers of various enzymatic reactions. For example, sodium and potassium are important in the transmission of nerve impulses. Without iron, not enough hemoglobin would be formed to transport oxygen and cause anemia. Lack of calcium can result in osteoporosis. Water is crucial to all life. We can live several weeks without food, but only a few days without water. The human body is about 65% water. Even dense bones are about 33% water. Water is considered the universal solvent. Basically, all chemical reactions in the body take place in water. Now we need to go over maybe some dry definitions in order to move on to the other classes. So we need to have an understanding of what some common terms are in nutrition and when it comes to reading labels and all that. So what is a healthy diet? A healthy diet fulfills energy needs with macronutrients. It provides sufficient amounts of essential nutrients, which are the micronutrients. It reduces the risk of disease, and it's safe to consume. Low contaminants or potentially harmful added substrates. Some other definitions. A requirement. Requirement is the minimum amount of a nutrient needed to sustain a physiological state, function, or structure in an individual. I've included a YouTube video there that I hope if you click on it, it will go through. If not, you might need to copy and paste or something like that. Anyway, recommendation. A recommendation is a normalized estimate of a nutrient needed to cover most individuals in a population group. And a guideline is advice on diet composition to population groups aimed at maintaining health and preventing diseases. So it's important to know the difference between a requirement, a recommendation, and a guideline. Essential nutrients. The term essential sometimes gets confused. Essential, in terms of biochemistry and nutrition, essential means that the chemicals cannot be synthesized by the body. They're chemical substances found in food. They're necessary for life, growth, and tissue repair. But the main thing that differentiates essential from non-essential is that they cannot be synthesized in the body. Definition of RDAs, or recommended daily allowance. The level of intake of essential nutrients considered in the judgment of the Food and Nutrition Board on the basis of available scientific knowledge to be adequate to meet the known nutritional needs of practically all healthy persons. The data for determining recommended daily allowances, adequate intakes, and upper limits, and all that are usually taken from metabolic experiments, which have their pros and cons, and food intake surveys, which also have their pros and cons. You can read about it in that slide right there. Dietary reference intakes, or DRIs, include estimated average requirements, or EAR, recommended daily allowance, RDA, adequate intake, or AI, and a tolerable upper intake level, or UL. So first, the estimated average requirement, or EAR. The average requirement for healthy individuals in which functional clinical assessment conducted and adequacy determined. Limited in number due to few human studies. Half of the subjects' needs are met at this level. 50% of subjects would not have their needs met. So that's an average. If everyone consumed an estimated average requirement of food, half the people would be getting plenty of that nutrient, half of them would be low in that nutrient because of their different metabolic needs. The recommended daily allowance is sufficient to meet the daily requirement of most individuals in a specific life stage and gender group. It's set at a level that is at the top 2 to 3% of the requirement distribution. It's intended to serve as a goal for daily intake of individuals. What they found was the average intake being being short for half the population was really not a good guideline. So they developed a recommended daily allowance, which included up to 98% of the population rather than just 50% of the population. What they did was they took the estimated average requirement, and you'll see, according to the bell curve there, if you take something like the amount of, I don't know, calcium that's needed in the diet. Well, everyone has different requirements for the amount of calcium that they need, depending on your level of activity, your fitness level, your gender, your age, etc. But the estimated average left half the people getting plenty and half the people being deficient. So they added 2 standard deviations above the estimated average requirement and made that the RDA, the recommended daily allowance. So the recommended daily allowance, being the EAR plus 2 standard deviations, covered the needs of up to 98% of the population. That RDA still leaves 2% of the population deficient if they consume that amount. So the RDA is equal to the estimated average requirement plus 2 standard deviations. Adequate intake is based on observed or experimentally determined approximations of a nutrient intake by a defined population or subgroup that appears to sustain a defined nutritional state. That can be used as a guideline to nutrient intake for an individual. The adequate intake is kind of an upside down bell curve, determining basically what's safe, what's an average safe intake of any particular nutrient. A deficiency of that nutrient would lead you with a risk of inadequacy, and having too much would run the risk of excess. So that adequate intake may be a little higher than the recommended daily allowance for some individuals, and it's kind of an arbitrary determination, not very scientifically accurate, but it's there nonetheless. The adequate intake may be used as a goal for nutrient intake for the individual. It's derived from intakes that appear to sustain a defined nutritional state. Usually they'll use like surveys of athletes or something like that to determine how much of a nutrient this group needs. The tolerable upper intake level is the highest level of daily nutrient intake that is likely to pose no risk of adverse health effects to almost all individuals in the general population, and is determined by risk assessment methods. It's not to be intended as a recommended level of intake. There's no evidence of benefit for healthy individuals in consuming nutrients above the RDA or AI, adequate intake. Dietary guidelines versus DRIs. The dietary guideline is a qualitative advice to the public about diet and chronic disease prevention. For example, the food pyramid. DRIs, the quantitative advice to professionals about amounts of nutrients found to be of benefit. Dietary guidelines include the USDA, the FDA, DGC, NIH, professional organizations, national nutritional and health goals, implementation of DRI by food assistance programs, nutrition education, in the food industry regulation. Pharmaceutical effects of nutrients are doses for therapeutic effect which exceed levels in food. Pharmacological action different from physiological function. Chemical analogs more effectively therapeutic than but have no nutritional activity. Okay, I hope that wasn't too dry for you. We will get into more interesting things as we go. So, again, I hope you learned a few things. I do believe in the motto of Hippocrates, let thy food be thy medicine, and let thy medicine be thy food. So I will see you next week. Again, there may be a little bit of a quiz. Food questions will be something like this. The main macronutrients that constitute the human diet are sugar and proteins, lipids, and nucleic acids, carbohydrates, proteins, and lipids, nucleic acids, lipids, and starches. If you don't know the answer to that question, you better go back and review these slides. But hopefully it's not too difficult, and the quiz shouldn't be too difficult either. I'll see you guys next week. Have a good one, and we'll go into class 2 at that point. Okay, bye-bye now.